Hi guys, sorry to put yet another disclaimer up, but I really wasn't expecting this video to be 40 minutes long, and truth be told, I probably should have split it in half. But I did kind of tell you last time that there would be Planet X in this video, so kind of wrote myself into a corner there. I know you guys have been waiting a long time for this video series about Planet X to actually have Planet X in it, so if you can't wait any longer, just click on that timestamp and it'll take you straight there. You won't need to do that much catch-up. On the other hand, you might listen to the whole thing and learn about Martians and seances and Halley's Comet killing everybody. Yeah, like I said, this is a strange story. Anyway, I really hope you enjoy it. Thank you. Being fired by Urbain Le Verrier could not have been a pleasant experience, but it was arguably the best thing that ever happened to Camille Flammarion. Surprisingly, Le Verrier fired the then 20-year-old student for daring to publish a book, The Plurality of Habitable Worlds, speculating on the existence of extraterrestrial life. You'd think Le Verrier, a man who not only discovered a planet, but idolized the fervent alien believer William Herschel, would have been more open-minded, but as we saw in the last episode, eccentricity comes in all flavors, and not just sweet. Flammarion may have smarted that day, but 30 years later, when his book was in its 35th printing, he doubtless recalled it with a smile. Flammarion would divide the remainder of his life between rigorous scientific endeavor and occasional descents into spiritualism, during which he explored such scientifically inexplicable phenomena as table turnings and table rappings. His ideas were regarded with a fair amount of skepticism, particularly by arch-skeptic Harry Houdini, who himself had already debunked many of these ideas years before. He also occasionally indulged in scurrilous journalism, most of it aimed at the man who fired him. He founded the Astronomical Society of France and would publish more than 50 books in his lifetime on a wide range of subjects, some on the cutting edge of science, some leaping screaming off it. Additionally, his journalist's instinct for hyperbole occasionally got in the way of his scientific objectivity. This was most apparent in what is arguably Flammarion's most controversial legacy, the Great Halley's Comet Panic of 1910. The return of Halley's Comet in 1910 was one of the most anticipated astronomical events in history. Not only was it the first since the invention of the camera, but predictions showed it would be an apparition of unparalleled beauty and awe. So closely would Halley approach our planet that it was scheduled to actually pass through its tail. Additionally, another recently invented astronomical tool, the spectrograph, had allowed Earthlings to finally begin to understand what those long mysterious objects actually were. Unfortunately, it would also reveal that among the plethora of complex organic molecules identified in Halley's tail, there lay the deadly toxin cyanogen. Imperfect knowledge is often worse than none, and when, on February 7th, the New York Times published an article saying that Flammarion had opined that, quote, cyanogen gas would impregnate the atmosphere and possibly snuff out all life on the planet, the result was national hysteria. The gutter press immediately jumped on the idea, feeding the public accounts of cyanogen and its effects. Quacks and charlatans sold comet pills, comet umbrellas, and comet gas masks to terrified customers, and revival meetings in the lead-up to the apparition were packed. A prospector in California even managed to crucify himself. Scientists, used to precise statistical language, often flail wildly when confronted with the press, and their repeated attempts to assuage the public that there was nothing whatsoever to worry about often made things worse. There was one man, however, with the verbal skill to cut to the marrow and state the necessary rebuttal, saying simply that the atmosphere of the comet's tail was, quote, so rarefied as to be thinner than any vacuum. He was, of course, right. Earth passed through Halley's tail with no ill effects. The man's name was Percival Lowell, and while he may have curbed Flammarion's impetuosity just that once, he was, and had been for some time, one of the man's most ardent disciples. Lowell and Flammarion had a great deal in common. They were both capable astronomers, but lacked formal qualification in the field. They were both fascinated by psychical phenomena, and published their own investigations into the subject. They were both gifted writers, who would often use their talent to communicate their ideas directly to the public while circumventing the tedium of scientific peer review, and they would eventually both found and run their own observatories. The two men thought highly of each other and of their accomplishments, and had once enjoyed a cordial dinner together. In many other respects, however, the two were polar opposites. Flammarion owed his observatory to the posthumous generosity of a rich admirer. Lowell required no such benefaction, as he belonged to one of the wealthiest families in America. The Lowells were part of an intensely gated and peculiar set of old-money aristocrats known as Boston Brahmins. Their wealth derived from the ancient agrarian economy of farming and textiles, but was facing competition from upstart new wealth from oil and industry. To set themselves apart, the Brahmins placed intense value on learning and education, and many would go on to respected academic and literary careers. Lowell's brother Abbott was elected president for the Brahmins' Holy of Holies, Harvard, in 1909, while his sister Amy won the Pulitzer Prize in 1926. Lowell would follow in those footsteps after a fashion, but his course would be very much his own. A standard career path was likely never an option for Lowell due to his volatile and turbulent personality. Craving recognition, he was simultaneously plagued by, quote, instabilities of mood and nerve, unquote, one of which incapacitated him for 4 years. After graduating from, of course, Harvard, with distinction in mathematics, he entered the family business and ran a textile mill for several years. In the 1880s, he became fascinated with the Far East, traveling widely in Japan, China, and Korea, and wrote several books on Japan and its culture, describing it in terms that today would be seen as shockingly racist, but were then lauded as, and I'm quoting here, colossal, splendid, and godlike. In what would be the first of several completely unverifiable ideas to seize on Lowell's mind, he came to the conclusion that Japanese civilization had ceased to evolve and begun to atrophy due to what he called the, quote, impersonality of Japanese culture, as opposed to superior Western individualism. It is interesting to ponder what Lowell's place in history would be today if he had continued this line of research, or indeed his research into Shinto trances and psychic powers. Instead, he read Flammarion's The Planet Mars, and in the process gained the cause that would consume him to the end of his life. Flammarion's book built on the remarkable discoveries of the Italian astronomer Giovanni Schiaparelli, who in 1877 completely revolutionized our understanding of the Red Planet. It had been known for some time that Mars was surprisingly Earth-like. Other than Earth, it was the only planet in the solar system not covered with impenetrable clouds, which meant that its surface features could be observed and mapped. Like Earth, it has a near 25-degree axial tilt, and thus experiences similar, though longer, seasons, during which its polar caps expand and contract. It also has a near 24-hour day and a tenuous atmosphere. These similarities led many, not least Flammarion himself, to speculate that it might also share the other unique gift of Earth, life. In 1877, Mars reached its closest point to Earth, known as opposition, which allowed Schiaparelli to test the limits of his new 470X telescope he had recently installed at his observatory in Milan. With it, Schiaparelli composed, by hand and without a camera, the first truly representative maps of Mars. So accurate were Schiaparelli's maps that the names he chose for the features he saw, Hellas, Argyre, Tharsis, Chryse, Elysium, and many more, are still used today, 130 years later. But as his maps grew in detail and complexity, they began to be overrun with strange linear features that he called canali, a word which in Italian means either channels, which are natural, or canals, which are man-made. Schiaparelli initially only referred to them as natural, but before long, the idea that they may have been artificial constructs of an alien civilization began to stir the zeitgeist. It is often said that it was the mistranslation of canali as canals that led to the idea taking hold, but since one of its earliest advocates was Camille Flammarion, who wrote in The Planet Mars that they were likely the construct of a more highly developed, quote, human species, that seems unlikely. French, like Italian, has one word for both channel and canal, so the translation wasn't an issue. It was simply an idea too captivating to contain. No one was more captivated with the idea than Percival Lowell. In 1894, after learning that Schiaparelli was going blind, he took it upon himself to further Schiaparelli's work and bring to the world the wonders of the Martians and their fabulous civilization. To that end, he hired William Henry Pickering, a junior professor of astronomy at Harvard, to aid him in the search for the ideal location for an observatory, to be completed in time for Mars's coming 1894 opposition. Pickering had done the first real research into ideal locations for astronomical observatories, so that they might, in Lowell's words, be built to see, not to be seen. Previous observatories had been built near their universities or the directors' houses. Pickering noted that a site far from city lights and in a high, dry environment produced the best seeing conditions. He had already put these ideas to test when constructing Harvard's Southern Hemisphere Observatory in Arequipa, Peru, but had been dismissed from the observatory by his own brother because he couldn't keep his mind, or his budget, on tasks at hand. After some backpedaling, he and Lowell settled on Flagstaff, Arizona, then a minor frontier town with little beyond a sawmill and a few general stores, as the best choice. Initially, Pickering thought he could persuade Lowell to act as a mere patron and grant title and authority to Harvard. Lowell was not having any of that. Almost uniquely for someone in his position, he desired nothing less than total control of what he insisted would be called the Lowell Observatory. From the beginning, it was fairly obvious how Lowell intended to deploy his newfound power. For its first 4 years, the Lowell Observatory remained open only during Martian oppositions, and was sited atop a 350-foot forested promontory he named Mars Hill. At a time when astronomy has shifted to the study of distant stars, Lowell's remit would be the solar system, specifically Mars, and more specifically, Martians. In May of 1894, Lowell gave a speech to the Boston Scientific Society in which he argued that, quote, "In them, i.e. Schiaparelli's canali, we are looking upon the result of the work of some sort of intelligent beings. The amazing blue network on Mars hints that one planet beside our own is actually inhabited now." More scientifically rigorous members of the audience, such as Lick Observatory Director W. W. Campbell, noted dryly that Lowell had come to this conclusion before even setting eye to eyepiece. After only 1 month of observations, Lowell blitzed the popular media with article after article about intelligent Martians, using his gifts as a writer to feed books on the subject to the ravenous public and deliver speeches to sold-out auditoriums. Lowell was not alone in arguing for a Martian civilization. During Mars's 1894 opposition, a bright light was seen on its surface, which inspired an article in Nature, to this day arguably the most respected science journal in the world. Quote, "The Martians, of course, find it much easier to see the dark side of the Earth than we do the dark side of Mars, and whatever may be the explanation, it is worth noting that forest fires over a large area may be the first distinctive thing observed on either planet from the other, besides the fixed surface markings." H.G. Wells cited the article in his classic opening page to his novel The War of the Worlds, suggesting that it had in fact, quote, "been the casting of the huge gun that in the vast pit sunk into their planet from which their shots were fired at us." Even Schiaparelli himself found the idea of the canals intriguing enough to publish 2 papers on the subject, noting in doing so that, quote, "once a year it is permissible to act like a madman." Lowell did, however, take his belief in Martians farther than anyone else, extrapolating from its supposed constructs the persona of an entire culture. Mars was slowly drying out, he said, and so for the sake of their own survival, the Martians had banded together as a species to construct these globe-spanning artifices that ensured that most precious of substances, water, could be had by all. For that, they must have renounced all conflict. In Mars is the Abode of Life, Lowell declared the Martians an inspiration for our imperfect race, citing, quote, "the necessarily intelligent and non-bellicose character of the community which could thus act as a unit throughout the globe. War is a survival among us from savage times, and affects now chiefly the boyish and unthinking element of the nation. The wisest realize that there are better ways for practicing heroism and other more certain ends of ensuring survival of the fittest. It is something people outgrow." Unquote. Would that Lowell had been as flattering to the Japanese as he was to the Martians. Lowell's maverick stampeding through the still newborn world of American astronomy was causing intense consternation. At the turn of the 20th century, observatories were becoming modern, rigorous academic institutions where research would be conducted and intensively reviewed by team players armed with the latest technology. Lowell used his own personal resources to take Lowell Observatory in idiosyncratic directions based on his own whims. In this, he managed to unify the notoriously competitive astronomical community against him, as they feared he might lessen the public's faith in science. Lowell simply had no patience for the scientific method. Rather than observe, test, and then theorize, he preferred to theorize first, and then use his observations to confirm his theories. He argued that the modern scientific man was deficient because, quote, "all the intellect goes into science, leaving nothing for common sense," unquote, apparently forgetting that the starting point of science is to leave common sense behind. A. E. Douglas, a colleague of Lowell's at the observatory, who had helped scout out its Flagstaff location, complained that Lowell, quote, is not credited among astronomers because he devotes his energy to hunting up a few facts in support of some speculation, instead of perseveringly hunting down innumerable facts and then limiting himself to publishing the unavoidable conclusions, as all scientists of good standing do. When Lowell heard this comment, Douglas was promptly fired. An acquaintance noted peevishly that Lowell, quote, would argue down deductively from some general notion, such as the supreme virtue of modernity, the impersonality of Orientals, etc. He only has 3 or 4, and bend the facts to suit the preconceived idea, seasoning the whole with verbal fireworks. George Ellery Hale and James Keeler, editors of the Astrophysical Journal, complained in correspondence that Lowell, quote, draws no line between what he sees and what he infers. Hale, Keeler, and Campbell had all observed Mars in detail, but had not seen any canals, and concluded that they were, quote, optico-psychic effects, i.e., optical illusions brought on by the mind. When Lowell argued for the presence of water in Mars's atmosphere, Campbell demonstrated meticulously that it was absent in an expedition to Mount Whitney. When, in 1905, Lowell claimed to have photographed the canals, his detractors noted the canals were thinner than the grain of any photographic plate. Schiaparelli, who met Lowell in 1895, noted that Lowell could contribute much to the study of Mars if he would only, quote, rein in his imagination. Perhaps the most comprehensive takedown of Lowell and his ideas came from Alfred Russel Wallace, one of the great unsung heroes of biology. I've actually spoken of Wallace and his accomplishments before, but here all that needs to be known is that his deconstruction of Lowell's canals is today regarded as one of the founding texts of astrobiology. In his short book, Is Mars Habitable?, he mercilessly destroyed Lowell's ideas about the canals. Quote, it appears then that Mr. Lowell has to face this dilemma. Only if the whole surface of Mars is an almost perfect level could the enormous network of straight canals, each from hundreds to thousands of miles long, have been possibly constructed by intelligent beings for purposes of irrigation. But if a complete and universal level surface exists, no such system would be necessary, for on a level surface, or on a surface slightly inclined from the poles to its equator, which would be advantageous in either case, the melting water would itself spread over the ground and naturally irrigate as much of the surface as was possible for it to reach. If the surface were not level, but consisted of slight elevations and depressions to the extent of a few scores or a few hundreds of feet, then there would be no possible advantage in cutting straight troughs into these elevations at various directions with water flowing at the bottom of them. Unquote. He noted that even if the entire polar cap were water, and its entire volume were diverted for irrigation, then the 1/3 of Mars supposedly under cultivation would have an average of 2 inches of water per square mile, 2 centimeters per square kilometer. Wallace speculated, correctly as it happened, that the caps were in fact frozen carbon dioxide rather than water. The only proof of the existence of water Lowell provided was the presence of, quote, blue bands that supposedly appeared when the polar caps retreated. However, Wallace pointed out that water cannot appear blue at such small concentrations. Lowell's ideas may have been rejected by science, but they would nourish popular culture for nearly a century. Until the 1960s, when the Mariner probes finally revealed Mars for the barren, cratered, and utterly canal-less desert it was, Martians were the go-to aliens to reflect our own anxieties about ourselves, from the imperialist cephalopods of War of the Worlds, to the stern patriarchs of The Day the Earth Stood Still, to the communal hippies of Stranger in a Strange Land. In 1938, a radio dramatization of the War of the Worlds was convincing enough to send people into mass panic. But by the 1970s, the jig was up. Humanity began looking further afield for its extraterrestrial demons and saviors. Today, when we think of Martians, we imagine not aliens, but ourselves. One question, though, still remains unanswered. If the canals weren't actual features on the surface of Mars, then what were they? Not a delusion, certainly, as they were seen by many people. The current belief is that they were some kind of optical illusion, as they were too narrow to have been visible at the magnifications available at the time. But the precise source of the illusion is still not settled. Some have argued that they were the result of a straining eye's attempts to connect disparate points together. Another is that they were a reflection of the veins in the astronomer's retinas. We may never know for certain. Some dragons are never put to rest. Percival Lowell suffered attacks from all sides from his scientific colleagues. But he was not one to retreat and lick his wounds. He had a plan. He would gain their respect. He would restore his reputation and that of his observatory. He would find the trans-Neptunian planet. The idea that there might exist another planet beyond Neptune was older than that of Neptune itself. Even before Neptune's discovery, Some haughty theoreticians were claiming that one planet alone would not be enough to explain the perturbations in the orbit of Uranus. The discovery of Neptune's moon Triton, less than a year after its planet, allowed for an estimation of Neptune's mass, which appeared a hair too heavy to account for every one of Uranus's movements. Before Neptune was discovered, the error in predicting Uranus's orbit amounted to 133 arcseconds, or a 27th of a degree. After accounting for Neptune's mass, the residual error was just 4.5 arcseconds, or about the width of a human hair at arm's length. But it was enough to set a few minds alight. Even Leverrier himself attempted a brief search before uncharacteristically abandoning it as impracticable. When rival scientist Jacques Babinet made some ill-considered claims about Leverrier's figures, saying that another planet had to exist beyond Neptune, Leverrier's response was prompt, and oh so very Leverrierian. Quote, "There is absolutely nothing by which one could determine the position of another planet, barring hypotheses in which imagination played too large a part." Unquote. Many others suggested hypotheses for a trans-Neptunian planet over the years, including, of course, Camille Flammarion, who in 1879 argued, in an eerie presage of more current events, that the comets we now know as Swift-Tuttle and Barnard II both had similar aphelia, or furthest distances from the Sun, suggesting that they had been tugged there by a more distant planet. Although his ideas raised scientific interest at the time, these days, 2 is not a sample large enough to be considered statistically significant. In 1901, French astronomer Gabriel Dallet also inferred the existence of a planet from the orbit of Uranus, referring to it as Planet X, or simply X. Lowell very likely read Dallet's paper, as his Memoir of a Trans-Neptunian Planet, published a year before his death in 1915, also refers to the hypothetical object as X. Eventually, and even after Lowell's death, Planet X would become the term of art employed by the staff of the observatory for the celestial object he sought for so long. Planet X could not be deduced from Neptune's motion, as that planet had only completed a tiny fraction of its orbit by Lowell's time, and apparently showed no irregularities. Computing its existence from Uranus's orbit was ridiculously complicated. Lowell's memoir contained 125 pages of tables and calculations. But for Lowell, they were enough to suggest that Planet X was real. Lowell concluded that Planet X was about half the mass of Neptune and about half again as far out from the Sun. Lowell's first search for Planet X commenced in 1906, in which Lowell examined 200 separate photographic plates with a magnifying glass, covering the whole of the ecliptic, the flat plane in the solar system where the planets reside. Over the next 4 years, Lowell made sporadic attempts to locate the planet, initially keeping it a secret before reasoning that, with what he was going through to try and find it, he was unlikely to be beaten to the punch. At least, that's what he thought, until 1908, when he attended a lecture by his old colleague, William Pickering. Despite their close association and common Boston to Harvard heritage, Lowell and Pickering had never got on. Lowell considered Pickering inconsistent and flighty, as well as an incompetent draftsman who recorded his findings with little care. Pickering, conversely, had come to side with Lowell's detractors over his claims about Martian life. When Lowell heard Pickering's ideas regarding a trans-Neptunian planet, which Pickering called Planet O, because it came after N, i.e. Neptune, he decided to redouble his efforts and launched further searches in 1910 and 1911. Writing in the margin, Lowell assessed Pickering's paper thusly, quote, "This ninth planet is very properly designated O, for it is nothing at all." Unquote. At this point, Lowell's assistant, the superb astrophotographer Carl Lampland, suggested that he invest in a blink comparator, a device that flashed 2 images one after the other, creating a brief animation that revealed any moving objects. Lowell declined, believing that the best solution lay in perfecting the mathematics. It was, as we shall soon see, a ruinous decision. In 1912, Lowell had one of his periodic moods, and was invalided for months by nervous exhaustion. By 1915, after years of searching had turned up nothing, Lowell had begun to lose hope. His pacifist ideals had already been shredded by the outbreak of the bloodiest conflict in human history, and his inability to restore his scientific reputation had begun to tell on him. On July 2, 1916, reportedly after erupting in anger at a servant, Lowell suffered a massive stroke and died. With Lowell gone, the Lowell Observatory at last donned the vestments of a normal scientific institution, thanks to the team of highly capable assistants Lowell had assembled, who became his successors. Chief among them, a dour, serious, taciturn man with a name straight out of a Hogwarts dungeon, Vesto Melvin Slifer. Despite sounding like he should have been wearing a high-collared robe and chanting in Latin around pentagrams, Vesto Slipher was in fact a supremely gifted astronomer who, in the 19-teens, wrote a series of papers outlining the evidence for the movement of galaxies that Edwin Hubble didn't figure out until the 1930s. It is odd to imagine a world with the Slipher Space Telescope, but it might have existed if history had been fairer. Surely, with him at the helm, the Lowell Observatory could rise above the ridicule and finally establish its credentials. I think you know where this is going. The Lowell Observatory was used to sustained attack from every corner. They had faced a collective turning of the backs from their astronomical colleagues who accused them of tilting at cosmic windmills. But nothing could have prepared them for their most vicious, most implacable, most unrelenting foe. Constance Savage Lowell, yes, that was her actual middle name, was Percival Lowell's wife, but for the life of me I can't comprehend how. Lowell was a man racked by anxiety and nervous maelstroms, often to the point of invalidity. If her behavior towards his observatory after his death is anything to go by, Constance should have driven him to suicide. I can only assume that the fact that they had no children must have meant that they had no physical contact whatsoever. Lowell's true love appears to have been his secretary, Rexy Leonard, whom he probably would have married in less prim times. She even wrote a book-length obituary for him called Percival Lowell Afterglow, which was more than Constance ever did. Lowell's greatest wish was that his life's work be continued, and that his observatory gain the reputation that he had failed to grant it. To that end, he left a sizable portion of his multi-million-dollar legacy in trust to aid the observatory's further endeavors. Well, Constance wasn't going to stand for that. Why let all that money go to people staring at stars when it could go to her mink coat collection? So she contested Lowell's decidedly incontestable will and locked the observatory in the courts for over a decade, with legal fees forcing its supremely dedicated staff to go on half salary. As a result, Lowell's legacy would be reduced by over half. On top of this, the death of her husband seems to have released something in her. Her usually argumentative and confrontational nature inflated into outright oddity. She would often lock herself away and, when forced to entertain others, pretend to be blind for no apparent reason. In one notable instance, the mask momentarily dropped when she exclaimed to a maid, "I see you brought me a cake," forcing everyone else to pretend they hadn't heard anything. Eventually, and inevitably, the courts found in favor of the observatory, and the search was on again for Planet X. In 1927, Abbott Lawrence Lowell, Percival's brother and the president of Harvard, gifted the observatory $10,000 to construct a 33-inch refractor, the first telescope ever designed expressly for the purpose of locating an undiscovered planet. Now all they needed was someone to operate it. This was a more difficult task than it seems, since that someone would have to work full-time, and no astronomer worth his salt was going to engage in such a tedious project. Then Slipher remembered some admirable astronomical sketches he'd just received from a farm in Kansas. If Horatio Alger and Norman Rockwell were tasked with constructing the archetypal perfect American life, it would likely resemble that of Clyde William Tombaugh. Even his name sounds like it comes complete with a catcher's mitt and a picnic table topped with homemade lemonade. In a line of solar system explorers bedecked with effete aristocratic names like Leverrier, Herschel, Cassini, Halley, and even Galileo, Clyde Tombaugh stands out like a mom-pop diner next to the Savoy. Tombaugh was born in 1906, the same year Lowell began his search for Planet X, in the small mining town of Streator, Illinois, one-time home of Happy Boy Evans, who wrote In the Good Old Summertime. His family were farmers, and Clyde had to work the farm from an early age, thanks to the shortage of manpower during World War I. His father taught his children to work with their hands, particularly with machines, to enjoy hard work, and to never ask for second chances. Always get it right first time. Skills perfect for a farmer, but also for an astronomer. Clyde was an unlikely prospect for college, but was determined to educate himself, and spent much of his free time reading. As if that wasn't enough, he was also a competitive athlete who played tennis, touch football, pole vault, and shot put. And he constructed a football field and a tennis court in his uncle's backyard. But it was his uncle handing him a telescope that sealed Tombaugh's future forever. Soon he was spending his nights at his uncle's house taking keen observations of the sky. Too poor to purchase a better one for himself, he went ahead and built one, and then another one when that one's mirror failed to focus properly. In this, he was aided by his family's move to Kansas when he was 17, because he convinced his father to construct a tornado shelter under the house, which also just happened to be the perfect location for grinding telescope mirrors. In 1928, when Tombaugh was 22, a hailstorm destroyed the family's crop, and he decided that farming was for fatalists. He wanted a job where he would have more control. On a whim, he sent some of his sketches and astronomical notes to the Lowell Observatory in Flagstaff, expecting just simple advice in reply. Instead, the letter he received made incisive queries about his physical health and his ability to work long, cold nights. It seems a position was open to operate a telescope currently under construction. The letter said nothing about Planet X. And so, on the word of a man 1,000 miles away whom he had never seen, Tombaugh spent what little he had saved doing odd summer work on a train ticket to Flagstaff, Arizona. As he boarded the train, his father told him, "Clyde, make yourself useful, and beware of easy women." On January 15, 1929, Slifer met Tombaugh at the train and escorted him to the observatory, and to the unheated room that was to be his home for the next several years. To Tombaugh, a man whose first experience of waves had been a visit to Lake Michigan, Flagstaff, at 7,000 feet, with desert vistas dotted with ponderosa pines, might as well have been another planet itself. Tombaugh was then told that his job would be to look for Planet X. Well, not really. His job would be to operate the telescope and image photographs onto massive glass plates. The job of searching those photographs for Planet X will be left to the real astronomers. 1 month after Tombaugh's arrival, the telescope saw what astronomers call first light, and exceeded nearly all expectation. And so, Tombaugh set to work, by night taking photographs, by day stoking the furnace, giving guided tours, and cleaning the snow off the dome, a job which required precision to avoid tearing the canvas. The job was, as he had been warned, long, cold, and dark, and required evading at least one mountain lion. Slifer and his brother would then search the photographic plates Tombaugh took for signs of moving objects. By now, they had invested in a blink comparator, which automated the task of shifting the plates back and forth. But even with it, the task seemed insurmountable. How could they tell the difference between a distant Planet X and a simple asteroid? By June, the Slifers had had enough, and handed the job of searching for Planet X to Tombaugh. Whether this was due to their belief that he was ready and capable enough to handle the job, or simply that they had given up hope and handed the lost cause to the hired drudge, Tombaugh never learned, though he speculated both reasons played a role. Tombaugh took to the job with hardly a murmur. The monotonous clack, clack, clack of the blink comparator may have discouraged anyone else, but Tombaugh had spent his youth tipping bales of hay into threshing machines, and the hours of scanning star after star were a picnic compared to his days at the farm. His skill at fixing machines even ended the recurring problem of the telescope holder shattering photographic plates, after Slifer had told him there was nothing he could do about it. But after a while he began to despair. His technique was slapdash and unsystematic, and made no allowances for distance. If Planet X was out there, it would not be found like this. It didn't help when Frank Ross, an astronomer at Yerkes Observatory in Wisconsin, politely opined, "Young man, I am afraid you are wasting your time. If there were any more planets to be found, they would have been found long before this." Thankfully, the observatory agreed to give Tombaugh the rest of the summer off, and of course, he spent it with his family in Kansas, including his baby sister, whom he'd never seen. Harvesting the season's last week before the autumn gave Tombaugh time to collect his mind, and after skimming a planetary almanac, he realized how he would find Planet X. Tombaugh's plan was rigorous, thorough, and above all, meticulously scientific. First, he ditched any of Lowell's predictions. If he was going to look for this thing, he would search the entire zodiac, the ring of constellations lining the ecliptic. Second, for every 2 plates he took, he would take a third to check for any flaws in the image that may have emerged from the photographic process. Finally, and crucially, he would only search the opposition point, the point in the sky directly opposite the sun. Tombaugh's reasoning was supremely elegant. As the planets move around the sun, they occasionally overtake each other like cars racing around a track. If you've ever overtaken a car on the road, you've noticed that the car appears to be moving backwards, even though it is only moving forwards. When the Earth overtakes another planet in the solar system, that planet appears to brake and then move backwards in the sky, a shift known as apparent retrograde motion. Since Planet X would be very far out, Earth would easily overtake it, and would therefore display retrograde motion at opposition. Retrograde motion gives a rough indication of distance. The slower an object's retrograde motion, the farther away it is. This would allow Tombaugh to exclude any bothersome asteroids or comets that might get in the way. Unfortunately, confining his search area to the opposition point meant that it would require an entire Earth year to search the zodiac, but Tombaugh was nothing if not perseverant. Months passed. Tombaugh checked star after star, constellation after constellation, keeping pace with the sun as it moved through the zodiac. Aquarius. Pisces, Aries. Nothing. 3 times a second, the blink comparator shifted back and forth, and Tomball recorded everything it brought to life. Variable stars, asteroids, the occasional comet. But of Planet X there was not a glimpse. And then, on February 18, 1930, Tomball blinked 2 plates he'd taken at the end of January in the constellation Gemini. It was getting late in the afternoon. He glanced at a small dot near the star Delta Geminorum. The blink comparator swapped the plates. The dot moved. Only 3.5 millimeters, but it moved. Such a tiny motion meant it had to be exceptionally far away, farther away than anything in the solar system. That's it, he half thought, half spoke aloud. His mind filled with the line from Keats. Now felt I like some watcher of the skies, when a new planet swims into his ken. What did Keats know? Tomball immediately went back to recheck his results. Carl Lampland, who had become used to the rhythmic clack-clack-clack of the blink comparator, began to notice that Tomball had fallen silent for 45 minutes. Either he was shirking, or he had found something, and by now Lampland knew Tomball well enough not to assume the former. Tomball called Lampland in for advice, and Lampland confirmed that it could only have been what they had sought for 25 years. Marching into Slifer's office, Tomball calmly and quietly informed him, "Dr. Slifer, I have found your Planet X." The reaction at the observatory was not as immediately jubilant as you might think. After the directors verified the object Tomball had found was indeed farther out than Neptune, Slifer and Lampland decided to keep it under wraps, on the fairly safe assumption that they were in no danger of their discovery being preempted. The reason was that, while it had been found just 6 degrees from one of Lowell's predicted locations, it was 6 times dimmer than he had assumed, and showed no disk, even under high magnification. Was it Planet X, or something entirely new? On March 13th, Lowell's birthday and the 149th anniversary of the discovery of Uranus, yes, coincidental birth and death dates are a running theme in this series, the Lowell Observatory stuck their flag in the sand and sent a telegram to the world declaring that Tomball's object was indeed Planet X. Systematic search begun years ago, supplementing Lowell's investigations for trans-Neptunian planet, has revealed an object which consistently conformed to trans-Neptunian body at approximate distance he assigned. 15th magnitude. Position, March 12 days, 3 hours GMT, was 7 seconds of time west from Delta Geminorum, agreeing with Lowell's predicted longitude. Slifer's intention was clear. This was to be Percival Lowell's planet. Clyde Tomball wasn't worth a mention. He was eventually credited in the astronomical circular Slifer sent out for publication. Once. 15 lines down. This planet was to be Lowell's and his observatory's redemption. Tomball took it all in his stride. He wasn't an accredited scientist, after all, though he did appreciate it when A.C. Crommelin, director of the Uccle Observatory in Belgium, credited him with the discovery, the only astronomer initially to do so. Tomball wasn't even granted the privilege of naming his planet. That would be the reserve of the observatory. Once the 9th planet made headlines across the world, they were not short of suggestions. Over 1,000 people wrote in from all parts of the globe, suggesting names from Atlas to Zymol. Constance Lowell suggested Zeus, Percival, and then Constance, a request Tomball later described as, quote, the final straw. Though you'd think that would have been the time when she tried to convince him that she had discovered Pluto and that Slifer had stolen the credit. Yes, that actually happened. As popular legend knows, however, the new planet would ultimately owe its name to an 11-year-old English schoolgirl. While it's hard to think of a better name for the planet than that chosen by Venetia Burney, it is nonetheless fair to say that its journey to the observatory's desk was sped by some fairly stellar academic connections. Her father was the Reverend Charles Burney, professor of Holy Scripture at Oxford, and her grandfather was Falconer Madden, librarian at Oxford's famed Bodleian Library. Falconer's brother Henry had even suggested the names of Mars's moons, Phobos and Deimos. After the death of her father and the removal of her brothers to boarding school, Venetia and her mother moved in with Madden, who noted the discovery of the New World while reading the Times over breakfast. Venetia had been reading Greek and Roman mythology at the time, and suggested Pluto, the Roman god of the underworld, would make a suitable name for a planet in the cold, dark depths of the solar system. Madden certainly thought so. He cabled the name to Herbert Hall Turner, director of Oxford's Radcliffe Observatory, who in turn cabled it to Slifer, On May 1st, 1930, Lowell Observatory staff unanimously chose Pluto as the name for the new planet. As a reward, Falconer gave Venetia £5, the equivalent of about £300 today, and a gramophone to help her singing, which she named Pluto. Tomball's reward from the observatory for rewriting astronomical history was a salary bump to $125 a month, much of which went toward keeping his family farm solvent during the Depression. A far more appreciated reward was a full scholarship from his home state to attend the University of Kansas, which he accepted gladly, only asking to defer a year so that he could wrap up his current observation timetable. It would set him on the road to full accreditation, though he likely better remembered it as where he met his wife Patsy. Despite eventually becoming arguably the most beloved planet in the solar system, Pluto was about to be led down a long and treacherous road, as first Planet X, and then Pluto, had their validity repeatedly challenged, and it is this slow degradation that will be the topic of the next episode.